Hi, this is Cycle 2, Week 6 Science, experiment number 4 in VanCleave's book, Thick. The purpose of this experiment is to give a practical demonstration of why Venus's atmosphere is so difficult for us to look into and for us to see into. It really is a demonstration of how certain materials diffract light and the ultimate effect that it has. In order to set up this experiment, you need a piece of wax paper, flashlight, and a table or a chair. You want to have each student can get to practice this experiment on their own. It's an easy experiment that everyone can do. In order to do this experiment, you take the flashlight and you set it at the very edge of the table. Position at the very edge of the table, and now we're going to move, the students are going to then move about 2 meters, about 6 feet away from the flashlight. So as I move, I'm going to take the wax paper with me. I'm going to turn the flashlight on. All right, so I'm going to move over here, about 6 feet away. Now, remind your students, they don't want to look directly at the flashlight. It's not like looking at the sun, of course, but it's still pretty bright, and so you don't want to do it. So they don't want to look directly at the flashlight, but they want to look at the light coming from the flashlight. Ask them how concentrated the light is. You know, if they do look at it at all directly, it'll hurt their eyes just a little bit, and they'll instinctively blink or turn their gaze away. Depending on the flashlight and how collimated the light is, the other observers may actually be able to see the light pretty well on the students. So maybe even see it in the shape of a circle as on the students. So we start with that image, and so the question is, what does the light look like from over here? So it's relatively bright, it's fairly well collimated. The observers looking in can see on the student the shape of the light. So now what we do then is we put in front of our face the wax paper. We separate from us and the light source. We put the wax paper between ourselves and the light source. And now the students can look very carefully, more or less directly at the light source. It's in fact difficult to determine exactly where the light source is coming from because of so much diffraction. The properties of the wax paper and the molecules therein, even though it's very thick, it's very, very thin piece of wax paper, but it's distorting the light, it's diffracting the light so that the light is relatively easy to look at, and the shape is still somewhat visible on the students, but it's nowhere near as visible as it is here, right? That's diffraction, a practical example. So the students are able to see it. This is analogous then to Venus. When we're looking inside Venus, when we're trying to look at the surface of Venus, we have to look through the atmosphere of Venus. Venus's atmosphere is not at all like our atmosphere, and in fact, the cloud cover of Venus is relatively thick. And so we're able to look into it only with great difficulty, and that's because the light that we're looking at it with is being diffracted. That's the essence of the VanCleave experiment number 4, Thick. I have a suggestion for an addition if you would like to add to your science table. So in order to do that, a little bit of prep work is required. So you set this up. So what I have here is a Tupperware. On the back of the Tupperware is a piece of paper. I've written a secret message. You tell your students. I've written a secret message to you, and you have to figure out what it is. And then on the outer layer of the Tupperware, I have another piece of wax paper held in place with a rubber band, and underneath that I actually have a piece of clear wrap or saran wrap. And the reason for that will become clear in a moment. So you start here and you ask your students, what is the message? Can you see it? Can you figure it out? Who can read it? No one can read it. You can't tell. In fact, it's very difficult to even tell that there's words written there. Right? Well, that's okay. You need a flashlight. So you hand your flashlight to your students and you have them turn it on. Well, now you can read it, right? No, you still can't read it even with the flashlight. Even with the flashlight. Why? Because again, the light is coming in and then it's bouncing off the hidden message and back to our eyes, but the property of the wax paper is distorting the light. It's diffracting it so that we can't clearly read it. So I take the rubber band off carefully, and then I take away the wax paper, and now we ask the same question. Can you read my hidden message? Yes. To know God. It's worth pointing out to the students that the saran wrap is here, and it's still there. So do you need the flashlight to read it? No, but if you use the flashlight again, beautiful assistant. Thank you. It's even clearer, right? If we
Well,
increase the light.
It's reflecting off of the
Oh,
saran wrap in the video, but in real time, you can see it easier.
Yeah, thank you. So if we turn the light off, then we see very clearly straight through. So the light is, the saran wrap has different properties, the molecules therein, and so it's not diffracting the light at all, which makes it relatively easy to see and to read the super secret hidden message. This is a good example that everyone can do. This is cycle 2, week 6, experiment number 4, thick.